Hi, today we're going to be talking about understanding interest. This unit, so like chapter 9.3 to 9.4, or 9.2, I guess. These chapters tend to be a little bit, either people get it or they struggle with it. I am the one who tends to struggle with it. Stuff that has to do with money and growth like that tends to hurt my brain a little bit. But we can walk through this and make sure it makes sense to you. So there are a handful of formulas that are important from I believe we're on 9.2. And these, I don't think you have to memorize them. It might be good to know the compound interest formula, the simple interest formula, and I think that they give you the APY formula, but I don't know if you'll need to know this one. And I feel like they might give you all the formulas, but it's good to know these either way. They look kind of intimidating, but we'll go through them. So the simple interest formula is interest equals the principal. I think they spell it with an A. Times the rate times the time. Now, you may or may not have heard the term principal before. Basically, what that means is the initial amount invested. If you remember talking about exponential growth a few chapters ago, basically, it is the A in our formula. It's how much you start with. So if you invest, say, $400, and the rate is 7%, you would do 0.07, because we want it in decimal form, not percent form, times, let's say you let it sit for 7 years. We want to know how much money we would have after those 7 years. So when you plug this into your calculator, you get 197. Now remember, our formula starts with I, so interest. At the end of 7 years, your account will have gained $197 in interest. Now, that doesn't mean that this is the amount that you walk away with. You still invested the $400. So if you have a question that's asking you how much you end up with, you will want to add these two together. Sometimes it will ask you how much interest you earned just by itself, and that would be when you use this 197. But sometimes it wants you to add those together. So that is the simple interest formula. Now there's the compound interest formula, which is our amount. Whoops, I forgot the U. Equals our principal, which, as we said before, is the starting amount, times 1 plus our rate over, I believe it is like how many times it compounds, which we represent with an n, and I'll get into that in a second, to the n times t power. This is an n times a t. So this one is saying this is the amount of money that you have after you plug it in with the compounding. Now this formula should look pretty familiar to you. It's very similar to our exponential growth formula, with P is equal to A is equal to P, 1 plus our rate to the time. But now we have some n's thrown into the bunch. Now what these n's sort of represent is, like, if you have a problem that is telling you that you want to invest and it compounds quarterly. This is basically how many times it compounds. If it compounds quarterly, that's 4 times. If it's semi-annually, that's 2 times. If it's annually, that's 1 time. If it's daily, it's 365. And if it is monthly, it's 12, and so on. So if you wanted to invest $1,000 and your rate was, again, let's do 7%. And let's say it compounds monthly. You'd put 12, and then you do 12 to the 12th times let's say in 4 years. Now, I will note, if you're plugging this into your calculator, when you do your up caret for the exponent, you're going to want to put the 12 times 4 in parentheses. Because if you just do the 12 to the 12th power and then times 4, it will think that you're timesing the whole thing by 4 rather than just the 12 times 4. You could also just do this math in your head before you plug it in, or do it on a calculator before you plug it in. So when I plug this into my calculator, I should get $1,322.05. So this would be our amount after those 4 years if we have it compounding monthly at a rate of 7%. And sometimes it will ask you how much interest you earned on that money. In that case, you take your principal and you minus that amount from your, it would be the other way around. You take that amount and you'd minus your principal from it, which would give you $322.05 interest earned, dollars of interest earned. So that's our compound interest formula. Our continuously compounding interest formula is not actually really related all that much to money. It's the amount equals our principal times e to the rate times time. Now this e sometimes confuses people. The e is not a variable like x. The e is a constant. It stands for like 2 point something. I don't have it memorized. It's a really famous number. It's seen a lot in nature. And anytime you see an e, you can assume it has something to do with nature. So it doesn't really have anything to do with money. I couldn't find any problems that were related to this. But if there are any problems on this 9.2 that deals with something like bacteria or things like that, that's a good hint that you probably will be using the PERT formula, the continuously compounding interest formula. It's also seen with, it's mostly like, it's very nature-y. Yeah. So the annual percentage yield is, so quoting Google here, it's the real rate of return earned on an investment, taking into account the effect of compounding interest. So if you had your compounding interest formula and you wanted to know what it would maybe be like in the simple interest formula, using the annual percentage yield might be effective for that. Now, you won't have to do any converting with the APY and then use the simple interest formula. Most of your questions that you will have that relate to this are going to be like, find the annual percentage yield of this. And it's going to be as a rate. That's why it has times 100%, because this is going to give you a decimal. And then this times 100% is just telling you that it's going to be in percent form. So that is going over the formulas. Let's get into some of the problems. They're a little bit tricky. And also, I know that this video is going to be kind of longer because we're going over kind of a more tricky, complicated concept. So just bear with me on this. So this first question says, determine the simple interest earned on $22,500 after 15 years if the APR, annual percentage rate, is 7%. So it's pretty much giving us explicitly what we need to do. We need to find the simple interest earned. So if you remember, our simple interest formula is I equals, I forgot. One sec. Oh, IPRT. I just wanted to make sure I had that right. I equals principal times rate times time. So we have 22500 times 15 times 0.07. And let me plug that into my calculator really quick. Okay, so I get 23625. Let me think about this for a minute. Okay, yeah, I'm pretty sure it's this 23,625. This question says that a couple deposits $22,000 into an account earning 6% annual interest for 15 years. Calculate the future value of the investment if the interest is compounded semi-annually. We're on to the nearest cent. So, we have some key words here. Compounded semi-annually. When you see something like compounded, you have a pretty good idea that it's going to be compounded interest. Now, it might not always, but it's a general idea. So it gives us our principal, it gives us our rate, it gives us our time. So 22,000 times 1 plus 0.06 divided by semi-annually, so 2 times to the 2 times 15. And when I plug that into my calculator, I get $53,399.77. Now, it seems like a big amount, but it is correct. So a couple deposits $24,000 into an account earning 5% annual interest for 20 years. Calculate the future value of the investment if the interest is compounded daily. So we have our keyword here, compounded daily. So our principal is $24,000 times 1 plus 0.05 divided by 365, because it's compounded daily, to the 365 times 20. And when I plug that into my calculator, I get $65,234.29. Well, we're rounding up, so it's 30 cents. The First Bank of Lending lists its following APR for loans. Determine the APY, or effective interest rate, for a loan that is between $20,000 and $99,999. And then we run around to the nearest hundredth. So, we don't care about this section, so we'll cross it out. And we don't care about this section either. So, if we look back to our APY formula, we know that it is our 1 plus, we need that in parentheses too. 1 plus 0.1199 divided by, and it says compounded daily, so 365, and then to the n, which is also 365, minus 1, and then we'll times that by 100. And we put the percent just to let you know that it's going to be turning into a percent rather than just keeping it as a decimal. When I plug that into my calculator, I get 12.74%, since I'm rounding to the nearest hundredth percent. Hopefully that made sense, what we did. When you plug into your calculator, be sure to put 2 parentheses first, instead of just 1. So this one is saying a payday loan is made for 4 weeks, where the amount of interest owed per $100 borrowed is $10. If you borrow $300 for 4 weeks, how much do you owe at the end of 4 weeks? Now this one feels tricky because it feels too easy. But the trick is that it is easy. So we borrow $300. That is 3 100s, right? 100 plus 100 plus 100. And we know that for every $100 borrowed, we owe $10. So we owe 10 from that, we owe 10 from that, and we owe 10 from that. So but also a very common mistake is people tend to put 30 in the box, but you still owe back the amount that you borrow, right? So you have to do $330 instead, because you borrow $300, but you also have to pay $30 in interest. Yeah. So suppose your salary in 2014 is $60,000. The annual inflation rate is 3%. What salary do you need to make in 2021 in order for it to keep up with inflation? So we have our principal, basically, are 3%, and we know it's an annual inflation rate. And we want to find out what we need to keep up with inflation. So we'll do 60,000, my bad. 1 plus 0.03 divided by just 1, which is 0.03, times, and then 2014 to 2021. That is going to be 7 years. So it's going to be to the 7th power. And when I plug it into my calculator, I get $73,792.43. Okay, so here's the last problem. Troy deposits $6,000. Determine the APY if there is an APR of 75% compounded quarterly. Round your answer to the nearest hundredth of a percent. So if we go back up to our APY formula, we know that the APY is brackets, parentheses, 1 plus, and then I forgot, R over N. Let me fix that. So 0.075 over 4, because it's compounded quarterly. And then I believe it's to the n, so it's going to be to the 4 minus 1. And then all of that times 100. And we'll keep the percent just to let you know. Let me do that really quick. I get 7.71%. Oh, nope, sorry. Oh, yes, correct. 7.71%. So, I hope that answers all your questions. If you have any more, please let me know, and I'll answer them as soon as possible. I know that sometimes I don't cover all of the problems that you might see in HAWX. That's really just because I either miss them, or HAWX just doesn't give me the same problems that you might see. It's sometimes HAWX is finicky. I think that's the right word for it. Anyway, yeah, have a good one. See ya.